So now looking at CLR first. So CLR have few basic important internals, right? So among which we have to look into 4 very important critical components we have as part of CLR, right? Which actually supports us to provide support for multiple language support, right? Multiple type supports and everything. So the 4 components are, we have CTS, which is Common Type System, right? So Common Type System, we have something called CLS, which is Common Language Specification, and then we have JIT, which is Just-in-Time Compiler, right? We have already had a discussion on JIT, and then you have something called GC, which is a garbage collector. Right, so very important components here. Now, starting with the first one, which is CTS. CTS is nothing but a Common Type System. Right. So here we know that .NET supports multiple languages. Right. So when we say multiple languages, the declaration of right, the declaration of variables or right or different keywords will be different in different languages. Right. For example, let's say in C# we normally say int to define integer. So don't worry if you don't understand what exactly I'm saying. Don't worry, we are going to get back and learn all the fundamentals of this data types and all. Right. So int here is nothing but your integer. It's a data type to handle numbers, to save some number and all. Right. So when you see C# it's int. When you see VB, it's integer, right? So which means you can see that there are different conventions, right? We use to define a single data type, right? So obviously, end of the day, there should be some component which derives, right? What exactly is this data type across, right? That single component is a CTS. You define any type of data type across all the languages. CTS understands, okay, if you're defining integer, which means we are defining integer of some 4 MB or integer as part of your language. So which means when it converts, when the MSIL is created, right, which is a intermediate language or a MSIL, Microsoft Intermediate Language, right? If you convert either C# int or a VB into one data type called int32. 4 bytes data type, which is int32 you have, where it will get saved. Fine. And then as soon as it is saved, right, definitely whatever data types we are using, on top of it your JIT will apply to convert it to right actual machine code or native code. Fine. So this is what is the main use of CTS we have, where it works with all value types and their reference types right across the multiple languages. Sorry, multiple languages we have. Right. So now that's our CTS. Now coming to CLS, which is language specifications. Right. Now this is the main component which actually creates the interoperability, which is language interoperability, right? Where we see that whatever syntax we normally define in C# will be completely different from the syntax which is defined in a VB. There will be no, there will be no connection between the way we normally define for multiple types here, right? Which is your CLS will take care of multiple syntax we have created. So while converting to MSIL, which is intermediate language, right? Definitely there should be a component which understands the syntax across the languages, right? Now this will help us to actually interconvert the syntax into the intermediate language syntax, right? Now CLR, can actually run more than 60 languages, right? And CLS is capable of, right, actually understanding all the languages and actually handling it as a managed code. So that is the importance of CLS here, where CLS is the main component which actually creates an interoperability feature for a .NET mainly. Coming to the next one, which is JIT, which is just-in-time compiler here. Now, anyways, we normally most of the times this JIT is common across programming languages. We also have JIT compiler in Java, right? Again, which takes care of a conversion. But anyways, we don't have something called multiple language, compilers and multiple compilers and converting to MSL. There is nothing like intermediate language. All these concepts, because we have one syntax in Java and it sticks to it, kind of, right? So just in time will actually triggers as soon as, right, as soon as MSIL code is created. So MSIL code is created, right, as soon as you start building your program. Once you're done with the program, as soon as you create MSIL, as soon as the MSIL code is created, it will automatically get triggered because it will be sequential way. It automatically triggers and it will take up the MSIL code and load on CLR to convert it to native code. So that is something called JIT, and JIT is a internal component of your CLR, right? Now coming to GC, which is garbage collectors, right? So garbage collector is the one which actually saves all the memory release, all the memory locks, everything. So in C and C++, right, generally, if you have, anyways, I mean, if you had C++ mainly in our academics, right, the undergraduate academics, so whenever we create any object or whenever we create any instance of any object, right, don't worry, even if you don't understand any of the term which we are discussing now, don't worry, we're going to discuss everything in our programming language when we actually start, right? Don't worry. Now, whenever you create object, normally what will happen is everything you do, everything you save, everything you instantiate, there is some memory which will be allocated, right? And definitely, when we talk about a memory, there are different types of memories here. We normally deal with virtual memory, which is called as the RAM memory, right? RAM, we normally have a RAM and processing speed and processors, multi-processors, right? And different types of processors, like if you have multiple, like 4 different processors mounted on X-way, we normally call this quad-core processors. I mean, all these configurations when you take, right, and when memory is allocated, definitely it is evident that as we start consuming the memory, you can see when I start this WebEx, and when I'm sharing my screen with you, definitely there will be some part of RAM memory or processing speed it will be taking up, because it has to start rendering. It has to start rendering the screen, which you can see. It has to start tracking my voice and pushing it so that you guys can hear, right? There are so many things which will happen in the background, for which we have to we need a memory. Now here, when we create a simple application of .NET, and let's say if you are using the memory, you are creating a bigger program to actually consume the virtual memory, right? And if you don't clear it, what will happen? There will be memory choke, which means memory choke is nothing but once you actually get out of your memory available in your RAM, that's it. The system will stuck. That's a memory choke, right? So it all happens with a program, how best program you're writing. But even with that, what will happen is, as soon as some objects or whatever is disposed or dumped or orphaned, right? There is one component called garbage collector which always clears off a memory. Now here in .NET, right, basically in .NET frameworks, memory allocation or memory management mainly is always done in a 3-compartment way, right? Basically, so what are 3 compartments we normally talk about? So here, when we talk about 3 compartments, let me just show you how and how the GC works. Let's say here, it's like a floor: first floor, second floor, and third floor. Let's say this is the first compartment, this is the second compartment, and we have a third compartment. So whenever we start creating any object or anything, right? .NET framework doesn't allocate memory randomly, right? Random allocation of memory will it's not a good management at all. Now here you can see this is the best way how the memory management is designed, right? So here, if you can see, let's say for this program, for example, right? Let's say you have some 2 GB of memory allocated, for example, right? So what will happen? Let's say there are 3 compartments here. Maybe first compartment, some 500 MB is allocated. Second compartment, for example, 500 MB is allocated, and let's say for third compartment, 1 GB is allocated. I'm just taking an example. This can be different, right? So as soon as I start creating objects, it will first start creating objects in first compartment, right? Let's say 1 object, 2 objects, 3 objects, and so on. And as soon as it fills, right, then the memory is not available in first slot, it will go to second slot. But when it is going to second slot, let's say 6 objects created, the garbage collector will be running continuously in all compartments. It will come to first compartment, okay, clear off whatever is orphaned. Go to second, clear. Go to third, clear. So when it comes to first compartment, right, you can see that when we are using second compartment, and you can see that in first compartment, object number 1 and object number 2 are no more in use, right? So immediately what it will do, it will dispose this and retain object number 3, because let's say if it is still in use, and then it will go to compartment number 2, which means still we are using compartment number 2 here, 6, 7, 8, but your compartment number 1 will be freed up with a memory. And let's say even if compartment 2 is filled, the garbage collector is still working on all layers, it will move to third compartment, right? So here let's say we are creating some 9, some 10 or it's going on. Now let's say compartment 1 again triggered. Now let's say there is no more in use, it got freed. Let's say in compartment 2, let's say 6, 7 and 8 got cleared. Garbage now here it comes. Now here you can see in compartment 3, yeah, I mean it is actually utilizing, and as soon as it fills up again, it will go to compartment number 1 to allocate memory, because by the time you come back to the right, garbage collector will be continuously moving on to all the 3 compartments and clears off whatever memory is orphaned. Orphaned is nothing but with the scope, automatically it will understand whether the object is connected or not. Right? Now this is how memory is managed, right? And obviously it won't be definitely easy. More than that, I mean it can eat up all the available memory as such. But I'm just taking an example here for you. Now this is how your GC, which is garbage collector, works in a round robin way to clean up the data again and again in each compartment. Right? So this is your GC, and these are your critical components mainly of your .NET. Coming to the next phase of .NET internals called base class libraries, right? Or generally sometimes you also call it as a BCL, right? BCL, right, which is a base class library, and we have a concept called UCL, which is a user-defined class library. I mean, anyways, whatever we are going to learn as a UCL, which is whatever class we are going to create is a user-defined class library kind of. But we normally follow the the layered structure, how the BCL is, whatever way the BCL is arranged. Now this is important. Right? And this is very important because the way the arrangement or we normally patternize the BCL, the classes, right, how it is actually designed internally is something which we will be following accordingly. And anyways, going to the specifics of base class service, there are so many base class services which we're going to see across throughout our training basically. Right? Now, the CLR, right, gives the complete support of execution of a program, and base class library provides a complete support on developing multiple features using .NET. That's a simple area, right? So now, first coming to the BCL hierarchy, right? Now, when we talk about BCL hierarchy, you have something called class library. Now, anyways, as soon as we normally complete this hierarchy, how it is patternized and arranged, we'll actually see. We'll actually create a sample project. We'll see the Visual Studio. We'll create a sample project and we'll see how execution is happening in today's class session. Right. So the first step is your class library. Now let me show this by comparing the folder structure we normally do have, right? When I say folder structure, it's a normal folder structure we normally maintain for saving our personal documents. The same folder structure I'm actually talking about here, right? Now, so a class library, let's take it as something called a drive. Let's say I'm gonna make it as a C drive. That's a drive. And class library is something which is combination of multiple classes. Simple as that. So here what we're going to do, every class library can have multiple namespaces. So very important and powerful concept called namespace. And if you know Java, right, this is a concept of package. If you don't know, much better, don't worry. We're going to see the namespace concept. This is something which is used to divide classes, right? Namespace is just a folder structure type we create. That's it, nothing else. And namespace defines the scope of class, right, which can be used where and all. Fine. So here, when we talk about namespace, now let's say here I'm gonna have namespace concept in my drive, which is my, let's say, C drive called, for example, movies. This is my folder, kind of, right? And in one class library, I can have multiple namespaces. Let's say I can have namespace 1, I have namespace 2, and so on. Right? Similarly, we have, right? I can have multiple. Let's say I can say movies, I can say documents, right? And so on. Right? Now, in each namespace, you can have something called classes. Right? The main code file, right, is a class. Right? What is a class? What are in terms of class? We'll understand in our once we start it. But under each namespace, you'll have a class file. Right? And I can have multiple classes. I can have class 1, I can have class 2, but I cannot have class with the same name. Let's say class 1, class 1. It is not allowed to create a pure complete class as with the same name. Right? Now similarly, I can have classes under namespace 2. Right? Because again it is a different. So let's say I can say class 4, class 5. And I can have something called, class 4, and I can have something called class, let's say 2 here again. And there is no relation between this class and this class because they are divided in a namespace type. right? So now here to check, to compare here, so let's say you have movies, and let's take an example of songs, for example. Now under movies, what we are doing is, let's say here I have a folder called English movies, for example, right? Right? And let's say I have something called as a Hindi movies. Let's take an example. Similarly, songs, right? I can have English again, right? And let's say I can have Chinese, for example. Now here, the folder English over here and here is not the same, because the bisection here is this English comes under movies and this English comes under songs. Simple, right? Whereas here, namespace is an actual folder and this is a file. Don't compare this folder with this, okay? This is a hierarchy I'm saying. Now this is an actual file, class file which we normally create, and namespace is a folder which will be virtual, and it will be created as a physical folder where it saves the classes in file. And we'll see this part, don't worry. Right? Now in this class we can have something called functions, which is a end code. This is a main code where inside a function you can write a code, the actual piece of code which is used to run. Which means, let's say English movies, for example, right? So here when we talk about English movies here, in I'm saying, let's say Hobbit, for example, right? So we created one end file. Now this is the end file, right? Now when I go and click a movie Hobbit, now it is not no more a folder, it's an end file which you can execute and see the kind of. Similarly, this is a function where actual logic is done, and as soon as I call this function, some action will be performed. Simple, right? Now in this way, I can have multiple functions, which means I can have function 1, function 2, function 3, and so on. Similarly, here you can have Hobbit. Let's say, you can have a Lord of the Rings, and you can have 300, whatever you want, functions. Similarly, in class 1, I cannot have same function with the same name. Yes, it is allowed in different way. What is the different way, we'll see. But same name, everything same, it is not allowed, right? Because I cannot create one more file with the same file type and everything in the same folder. It's a similar structure we have, right? And similarly, let's say here I have a class 2 or maybe class 1 again here, right? Maybe I can create again functions, let's say function 5, function 6, or maybe I'm going to take function 1 again. Now function 1, even if or 2, whatever, same function I'm writing here doesn't have any relation with this 2, because this belongs to class 1 of namespace 2. Again, let's say when I'm talking about English, let's say here again I have something called Hobbit. Maybe it's all the background music of Hobbit is a audio format. So you can see the hierarchy of English Hobbit is same, but they comes under different settings. That's your function file. Now this is the hierarchy of your classes, which is you will have a class library, you will have a namespace, and under namespace you have class, and in a class you will have a function. Simple. This is a complete hierarchy we normally follow for creating of any class or any piece of code in a class. Clear? Any questions, guys, still here? Right? Now this is about your hierarchy of class we normally have. And always do remember, I just gave this example to you because this is a normal way, right? We normally arrange our folders and files in our system. It can be a system or it can be mobile or whatever you want, right? We normally arrange our things so whenever we want, we can actually go back and check and retrieve the files we want. Right? So that is about something called your hierarchy of your process. So any questions till now, guys? Okay, good. So if we are clear, now let's move on and we'll see how to tag or how to create a project and what is a project now, and we'll compare the project terms here with this. Okay. Now, first let me open Visual Studio. Right, I have Visual Studio 2012 installed. Right, let me click on it. Right. So here, anyways, I hope you guys would have seen the Visual Studio installed and open. But for the first time, if you are actually opening up, right, you will actually have, it will ask you which language you want to select, and you can select any one of the languages which are default, kind of like C# or whatever language you need, and your Visual Studio settings will be set to by default that language. And by default, I have actually set to my language as C#. So first, let's go and create first project. You can go File, New, and a Project. Right? So let me go Windows. So we are going to learn everything in this project. Now, first let's understand this window. This is a very important window, right? Which will give us, this is called as a new project, the wizard window normally, right? And here we have to understand few things which are very important. First thing. Now let's look at the extreme left part. Now this is something which are different project types we have. Now when we talk about project type, right, it can be your web application, it can be your desktop, which is called as a Windows based application, right? It can be your class library, it can be your web service. It can be your, when we say web application, it can be your ASP.NET application, it can be your MVC application, it can be your WCF. Right? There are so many types of applications which you can run. Now, how to create them? Anyways, we have a predefined templates. Right? See, end of the day, when we say web application, which means in .NET you are using base class libraries which can help us to develop the web application. Simple. If you want to develop a WCF, again we have to just use base class libraries which is called as a service model libraries to develop a WCF. Simple as that in general. But maybe sometimes if you don't remember them, you can just go ahead and select your project type. Simple as that. If you want web application, when you select it will give all the web types. You can see ASP.NET, MVC. If you go to Windows, it will give you console application, class libraries, and so on. If you want WCF, you can see it will create a service, right? If you want to create the cloud, you can see Azure, SDK, you can create, right? It has got everything. And by default, you can see it shows Visual C#. Right? Why C#? Because I have set my project, I have set my Visual Studio to default it with the C# language. That's why my language is set to C#. It doesn't mean that I cannot create in the other. You can see there is one option called other languages. So, and it will give us the basic languages like VB, C++, JavaScript, Sharp. It will give us some. So when I said VB, you can see the complete hierarchy of Windows, web application, right? Web application we have, right? Again your WCF and all type of applications you have VB. Because VB and C# are like mostly used languages for .NET applications, right? So this is your extreme left we have, which is called the installed templates. Anyways, you can go online and you can get more, right? So that is something which you don't even need, because installed applications are more than enough. It will give you all type of applications more, right? And even in a multiple languages kind of, right? That's your symbol. Now this window which you can see here is, as soon as select something, it will give you in Windows what different type of specific project types you can create. You can create console, you can create Windows Forms applications, WPF, Windows Service, right? Class libraries, and so on, right? This window file types completely depends on framework. See, this is very important. If you remember, I said when we were learning our framework, right? Framework. Sorry. Yeah, here. Right? If you remember, as I said, now these frameworks are interdependent, few versions, and we can install them side by side. What is the meaning of side by side? The meaning is I can have multiple versions of .NET Framework installed in a same machine. Why? You can see I have a .NET from 2.0, 3.0, 3.5, 4, 4.5, and 4. You can see there are multiple versions of .NET Framework I have, and I can select which version I want to develop my application. See, when I select 2.0, you can see there are few type of applications I had before, right? Similarly, if I select maybe 3.0, right, it have added some more. I select 3.5, maybe some more, or 4.5, right? It all depends on what type of framework I'm using, and based on the framework, the project types may increase. Definitely, right? Because when the version is increasing, you are getting more and more features. Simple as that. When you're getting more and more features, there can be more and more project types. That is a window which is dependent on a framework you are selecting, right? Which is one. Let me select a console type of application. We are going to see console. Now that's your window. Anyways, this extreme right is something, as you select something, right, it will actually give you what type and which type of language you're using and what exactly it will be tested. Now here, extreme bottom section is again important. Now what we are doing, we are creating a project. Let me just explain this. This is very important. We had a discussion on class library, right? If you want to create one class library, then we will be creating something called one project. For example, project 1, and I can create multiple projects. See, this project is the one which combines, right? You can't write code in .NET directly on it. You have to create everything in a disciplined way. Then that will start from a project. Each project can contain multiple namespaces and multiple files, multiple web pages, and multiple classes. Combining all these sources, we call them as a one single project. And once you give the binaries or some layout, we normally call it as a libraries or assemblies. And in this type of libraries, I can create any number of libraries I want. I can create any number of class libraries. Similarly, I can create multiple projects, right? Now, when you are creating multiple projects, there should be one parent for all, right? And that parent is called as your solution, right? Very important. Always, even if you create one project, solution is created for sure, right? Without a solution, you don't have any project. So here it will be creating solution, and then inside the solution it will create a multiple projects, and inside the project again it starts your namespace, class, multiple files, and so on. Anyways, we're going to create the one. So now you can see here two things. It says name, what name you want to give. Right now this is something which is called a project name, because this window is a project. Right, and it is asking for where do you want to create a project. Definitely you have to provide some space hard disk to provide this. And the solution name. This is important. What is the solution name? Because this is the first time we create thing, and you can see this space here is a solution explorer. You can see all the files and everything in a tree hierarchy here. For now, I'm creating a brand new solution because there is no nothing. So first let me give this name of project as my first project, or I'll say my first. As soon as you give the name of a project, it will also create a solution with the same name. But I don't want the name of solution to be same as this, because I'm going to create multiple projects, or rather I'm going to use the same solution for my entire training for every type of project. Right? So here let's say I'm going to make it as October batch. I'm going to call this solution name as October batch solution. Simple as that. Right? So now let me create. Let me just open up some folder path. So let me open use this path, which is my normal path I have. And here you can see it says it create directory for solution as source control, which is a source like TFS. If you have, you can directly add. Now here I'm going to create a code. Now let me click on OK. Now when you click on OK, now this is creating, right, a complete solution, a complete project, and a complete complete files for you in a project. Now you can see this is a hierarchy. You have a solution named October batch, and then in this solution you can see there now we have one project. Sorry, that we have one project, and that project is called as my first. Now if you want to see it in, don't worry about these guys. We're going to come back here, right? If you want to see this in a folder structure, you can see this. Right click on this and go to open folder for File Explorer. You can see this is a code file, right? Inside the code, right, which is the path we gave. Inside it, I have a my October batch, right? The October batch is a solution file. You can see if you want the type Microsoft Visual Studio solution. This is a solution file which contains the details of all the projects and the link and everything about your solution. So and in this folder you can see there is one subfolder called My First, right? And this My First is nothing but your project. Now if you go inside, you can see this is your project file. You can see here there are so many files. We'll come back to this step by step. Don't worry. You can see My First, which is your Visual C# project file. Now all these things definitely they should be connected with one or other project files. Otherwise we don't understand how it actually goes. Right? Now this is the project. Now inside this project file, let's see, open up. Now there are some important stuff which we have. First thing, you can see as soon as I create my console type of application, it will create a default class file called program.cs. Now this is my class file, and you can see the extension is CS, which is called as a C# program.C#. And inside this file, you can see there is some piece of code which got auto-generated. We'll come back to this later. Over. Right? And in this, first let's understand different files here. The first thing is your properties. For every project, there will be some property set, right? So if you want, now anyway, this option of properties will give you this assembly properties. But if you want to see the name and all, right click on this My First and say properties. If you open up the consolidated properties window, here you can see the assembly name. Assembly name is nothing but okay, fine. We have a project. Once you're done with developing a project and all, what is the final exe or a binary or assembly or class every name you want to give for this project is your assembly. And you can see it says default namespace. Right? Definitely namespace should start from one of the default, and I can create any number of namespaces within and across. You'll see that part. No worry, you'll see that part. Fine. And you have target framework, right? Because in this we have selected as the 4.5, and anytime you want to change, you can change. But backward compatibility, as we discussed, backward compatibility of .NET applications are not supported and recommended until you are ready to do a complete reprogramming of a backward framework. Let's say we developed everything in 4.5, and sometime later you want to move everything to 2.5. Right? Definitely, I mean you should be ready with your recoding part, because until unless you decode, right, it will definitely go cannot backport automatically. It doesn't do that, right? And then you have very important thing called assembly information. Assembly information is nothing but for every exe or anything you have seen this part, right, we're getting, right, we'll have a name of that exe and which version of software we're using and copyright to which company and product and company, all the restrictions will be there. Now that we're going to set it here, which is our assembly information. So, and you have a project called output type. Now anyways, as we have created this, it's a console type anyways, and you can actually have a, you can convert to these type of your properties in your, that's your properties. Anyways, if you go to properties assembly, right, now this is this will give you only assembly, but anyways, as soon as you change something in assembly here, it will automatically get affected here. So that's worry. That's your, sorry, that's your properties. And then very important thing is your references. Now here, the project type, when you select, right, we are selecting project types and all to get the right reference libraries are. Now anyways, when you install your .NET framework, all the libraries, right, whatever we need, which is called as also base class libraries, we need to develop different applications will get saved in our machine, right? So that is something which will. Sorry guys, there was any question? Okay, right. So the library which will get saved by default, right? So now you can see that system is one of the core namespace we have. System is a very important namespace under which there are many classes defined. Anyways, we're gonna see all the base class libraries under system more and more. No worry. That's why you can see that there are system.core, system.data and so on. Anyways, we'll come to specific data. Now these are libraries we have under the references, which will be added to your references in your project. Now, based on the project type, tomorrow once we create a web application, the references will be different. References will be your components which are related to web. Similarly, once we create WCF, related to WCF, similarly, and so on. Right? And then you can see configuration file. This is something which is called as a configuration. Right? Now, when you build the configuration files, right, these configuration files always stay in a raw format. Right? Now, whatever you want to change, right, tomorrow, let's say I want to change some properties of application and apply. You don't have to come back, code again and give it. No, just take, parameterize them and give it here, configuration file. And once you change it in configuration file, it will get affected. That's how the config file works. And the last one, anyways, is your class file. This is your class file, right? Now, anyways, we're gonna see more about class file internals and execution and build everything in tomorrow's class, right? Because we need one shot of a class to understand the basic execution model, how binaries are created, how build is happening, everything, right? So which we'll actually see it in tomorrow's class. Now this is how we normally create a project and a solution, and you can create multiple projects in the same solution.